October-November 2014, Paper 5-3, question number 1. A golf ball B is projected from a point O on horizontal ground. B hits the ground for the first time at a point 48 meters away from O at time 2.4 seconds after projection. Calculate the angle of projection. This question is for 3 marks, so it should be straightforward. Let's set up the diagram first. So we have a golf ball B at point O on a horizontal ground. Let's assume that this ball is being projected with an angle of theta degrees and with initial velocity u. This will be the motion of the ball, and after 2.4 seconds the ball will be at this point, which is 48 meters away from O. The question is asking us to find this angle. Let's begin. To solve this question, you first need to know the horizontal displacement and the vertical displacement. Instead of theta, I will be using n because this software works better with letters rather than Greek characters. You should be knowing from your lessons that the formula for the horizontal displacement x is given by u, which is the initial velocity, multiplied by cos theta multiplied by the time taken. It is given that the time taken is 2.4 seconds and the horizontal displacement is 48 meters. Substituting the values, we get u cos n into 2.4 is equal to 48. Simplifying this, you should be getting u cos n is equal to 20. Let's call this the first equation. Now, we need another equation in terms of u and theta. We can obtain this by using the vertical displacement formula, which is given by u sine theta into time taken minus half gt square. We can see that the ball at initial and final points is on the same vertical level, which means that the vertical displacement is 0 and time is 2.4 seconds and gravity due to acceleration is 10 meters per second square. After substituting the values in the vertical displacement formula, we get this equation. Simplifying this further, we should be getting u sine n is equal to 12, which is u sine theta is equal to 12. Let's call this the second equation. Now, in order to eliminate u, let's divide equation 2 by equation 1. Both the u's get cancelled, and now we're left out with tan theta is equal to 12 by 20. Using your calculator, we can get n or theta as 30.96. Remember to give it to 1 decimal place, which leaves us with an answer of 31 degrees. Therefore, the angle of projection is 31 degrees.